Hey math kids, today we're going to talk about growth and decay. And so we'll just jump in with an example. A scientist is modeling a grasshopper plague. The area affected by the grasshoppers is given by if n equals 1000 by 1.15 to the n. Okay, where n is the number of weeks after the initial observation. So first they want us to find the original affected area, and that's just going to be represented right here. So original area is 1000 hectares. Okay. Now B, find the affected area after 5 weeks and 10 weeks. So all we're going to do to figure that out is plug it in to this formula with a 5 for n and then a 10 for n. Plug in a 5, plug in a 10, plug it in. For this one, we get, and this one, we get this. Okay. Now C says to draw the graph of the affected area over time. So we're going to make a graph. And the next, let's see. Okay, we want to make sure we go up to 8,000 on the because the next question asks about 8,000. Okay, and I guess let's just do 2s. 2, 4, 6, 8, 10, 12, 14, 16, 2, 4. Okay, now we can plot the points that we know. So we know initially we're at 1,000, so that's going to be right there. We know at 5 we were at a little over 2,000, and at 10 we were at a little over 4,000, so maybe like that. And so if we connect the dots, we do that. And then part D says use your graph or technology to find how long it will take for the affected area to reach 8,000. So whether you do this on using technology or just like this, looks like it's close to 14, maybe 13.5. Your book's graph is a little more precise, and they ended up getting about 15 weeks. But from our graph, you just go over 8,000 and then go down, and it looks like 13.5 weeks is when the affected area is 8,000. Okay. And it looks like we have just one more. This time it says when a diesel electric generator is switched off, the current dies away according to the formula. So this is how the current, like the electrical current, dies off. Amps. And it says T is seconds. Okay. So they want us to find I of t when t equals 0, 1, 2, and 3. Okay. So we're going to find I of 0, I of 1, I of 2, I of 3. So all we need to do, plug in a 0 here, this goes away, so that's 24, which is, once again, just the initial amount. Okay, if we plug in a 1, it's going to end up being a 6. If we plug in a 2, that's going to give us 1.5. These are all amps, by the way. And then if we plug in a 3 to this, it's going to give us 0.375 amps. Okay, so I would just use a calculator, plug in the different values for T, and then you'll end up with these answers. Now B, what current flowed in the generator at the instant it was switched off? Now, that's just when T equals 0, so it's just really asking for this, but on a conceptual level. So part B, that's the answer, 24 amps. Part C says plot the graph for T is greater than or equal to 0 using the information above. So we're going to do 0, 1, 2, 3, 4. And then let's just do 5, 10, 15, 20, 25. Okay, when we turned it off, we had 24. And then after 1, we were at 6. After 2, we were at like 1.5. And then at 3, we were super close to 0, but not quite there. Okay. So we have an exponential function that's going down. And then the last one, it says, use your graph or technology to find how long it takes for the current to reach 4 amps. So 4 amps is about there. And then we go down from there. And at least according to this, it's about 1.3. And your book got about the same thing. So I guess my graph was a little bit better on this one. Okay, if you need additional help, please come to Math Lab. Until then, calculator.